For those that may not be familiar with the International Residential Code, the IRC, can you walk us through its prescriptive methods for residential wind bracing? What makes it an essential part of residential structural design?
The IRC is designed that if you follow it, you're going to end up with a safe home. Most of us, we go home and like you're working on huge projects, but we all go home to a residence. And for the most part, it's been designed and constructed under the
Did you know that residential homes in the US are designed to withstand powerful winds using a set of rules laid out in the International Residential Code, or the IRC? But many engineers still find its wind bracing provisions confusing or overly complex. Getting it right can mean the difference between a better home that stands and one that falls under pressure. In this episode, we'll be breaking down how the IRC's prescriptive method really works and some software that can help simplify it. Joining us today is Jim Collins, Ph.D., PE, and Director of Structural Engineering at Keystone Custom Homes. Jim has a deep experience in residential design and a passion for improving how engineers approach code compliance. We'll be talking about the fundamentals of IRC wind bracing, the innovations behind Jim's automated bracing software, and his improved Gable end details that could make residential structures stronger and more efficient. If you've ever struggled with code interpretation, field implementation, or want to see how software can be used to improve your workflow, this conversation is for you. Tune in to gain actionable insights you can apply to your own projects and see residential engineering through a sharper, more informed lens. Before we jump in, I want to tell you about AEC PM Connect, an event designed for structural engineers who want to lead more effectively and deliver projects with greater impact. You'll explore topics like AI and project management, earned value tracking, and people leadership. And here's the exciting part. At this event, we'll also be announcing the winners of the AEC PM Awards, recognizing professionals who lead with purpose and deliver measurable results. Just imagine someone from your firm being named AEC PM of the Year. That kind of recognition can boost your people, your culture, and your firm's reputation in a big way. The event takes place June 10th, 2026 at the Forest Gate Country Club in New Jersey. You can register now at aecpmconnect.com. And if you want to nominate someone for the awards, head over to aecpmawards.com to download the nominations guide before the deadline on February 28th. I'm your host, Matt Picardle, and this is the Structural Engineering Channel. Jim, can you tell our listeners a little bit about yourself and what got you interested in structural engineering and how that journey led to you as your current role as Director of Structural Engineering at Keystone Custom Homes?
Sure, Matt. I have been licensed since 1989. That's been a long time. In college, I went to Rutgers, and I really wasn't sure what field of engineering. I knew basically it was going to be civil, but I wasn't sure. I was interested in heavy equipment construction. I was interested in, actually looked at industrial engineering because I thought that was potentially interesting. But structural engineering it caught my fancy, for lack of a better term. And so at Rutgers back then, you get an emphasis in structural engineering. It wasn't a degree per se, like some colleges or universities. And I think when I took concrete design, I kind of realized that this could all be not automated, but it's very mechanical, right? So I started writing flow charts as a student and did very in-depth flow charts for myself. Just by doing that, I learned how to do it. But the exams were open book, and all of a sudden I started getting hundreds on my exams. And the professor, E.G. Nowie, eventually called me over and says, Jim, like, what's going on? You finish early and you're getting everything right. Flow charts. And doggone it, later on, one of the books he wrote, like he incorporated that into his books. And I quickly became like everybody's best friend in concrete class, right? But that was the beginning of my interest even in software development. And my professors encouraged me to stay on for my master's, which I did. High strength composite partially pre-stressed high-strength concrete beams, T-beams. At the time, I think it was Naaman out of Chicago, or Naaman out of Chicago was doing a lot of research, intermixing mild steel with pre-stressed tendons. And so I designed a lot of beams and tested them, instrumented them, and got my master's based on that. And then I had a friend who started teaching at Stevens Institute of Technology. He graduated from Rutgers with his doctorate, and he called me up. He said, Jim, they have an affiliate instructor position. If you pass your qualifyings, they'll pay for your tuition. And I said, well, that wasn't what I was planning to do, but I gave it a shot and ended up getting a doctorate from Stevens. But the real benefit is, as an affiliate instructor, I had to teach everything, all the undergraduate civil engineering courses, plus some
Mm.
mechanical courses. And that's when I really learned everything that I should have learned as an undergraduate, right? You can't help when you start
Yeah.
teaching, right? It's like you better know it. But academia wasn't for me. It's really difficult to bring in funding, to do research, publish, and to teach, and do them all well. And I decided I couldn't do all of them well, so I left. And I spent a quick overview, probably 14 years with engineered wood. I've worked for Trust Choice, Roseburg Forest Products, and moved around the country a little bit. Also worked for Alpine and Mytech. I have maybe 7 or 8 years experience in the truss industry. I was also, for a couple of years, I worked for ICCES. I was their director of engineering in LA when they were still in the Whittier office. But it's all been more or less around residential construction. And I'm home-based out of my home in just north of Baltimore. And I started a job. It was a startup company, off-site fabrication company in Baltimore. And they lasted about 5 years and eventually folded up. But that's when I met Keystone Custom Homes. They're a custom home builder in Lancaster, Pennsylvania. They build in PA, Maryland. We're now in both North and South Carolina, and just recently in Virginia. And it's just been a really good fit because I've got a broad background of residential construction codes and standards, a little bit of software development, and just have a foot in both or many different parts of the construction process.
Yeah, it's really interesting. It's the same thing for me. It's in terms of how I got into structural engineering, taking those classes, and then something clicked where I was putting it all together. I wasn't too into math, but then when I took those design classes, something clicked where that really resonated with me. And that's when I started to, get my master's in structural engineering, committing to that. And what's really interesting too is I remember looking at the website at Keystone Custom Homes. It looks really cool. It's almost like, hey, I want a new home. All right. They make it so easy in terms of here's a step-by-step process, and here are some of the plans that you can lay out. So I wanted to get into that because I think the stuff that you're doing is pretty cool. But for those that may not be familiar with the International Residential Code, the IRC, can you walk us through its prescriptive methods for residential wind bracing? What makes it an essential part of residential structural design?
So to begin with, most residential structures in our country are considered to be non-engineered construction. Again, I say most, not all. California is an exception, parts of Florida and other states. But it's basically considered non-engineered, which means that the IRC, the code itself, is written to be followed, kind of like a cookbook or recipe.
Okay.
And it's, I'm not going to necessarily get into the ICC process of how code development is developed. It's a detailed process. A lot of industries are involved in that to make sure that they try to bend the code a little bit towards their advantage or their favor. But the IRC is designed that if you follow it, you're going to end up with a safe home. Much like if you use, I'm going to age myself here, Matt, but a Betty Crocker cookbook, right? We don't have to be professional chefs to make a decent meal. Now, what we end up making, not to knock Betty Crocker's cookbook, what we end up making, that meal may not be ready to be served in a a fine dining restaurant, but it's going to be a decent meal. But we don't have
Hmm.
to know anything about what a professional chef would know. We just don't.
Okay.
There's no calculations per se. You don't need to be a PE to just kind of read through. So that's the premise. And to be honest with you, most of or a good part of my career, I always viewed the IRC. Forgive me, I'm going to make some people grumpy here. It was like woo-woo code from La La Land, right? It's like
So,
it's not real, right? There's no engineering, there's no calculations, there's no equations per se. But it turns out that most of us, we go home and like you're working on huge multi-billion-dollar projects, but we all go home to a residence. And for the
uh-huh.
most part, it's been designed and constructed under the IRC, which means that our family, our spouse, our partners, our children, they're all being protected from the wind, from earthquakes, from snow, from rain, based on the standards of the IRC. So it really is important if you're as a structural engineer, if you have anything to do with residential design and construction, to make sure that you do understand what's behind the IRC. And as a PE, I think most of us who have tried this know that there are certain areas that you can't calc out. Like if you follow ASCE 7, IBC, ACI, whatever, and you follow the exact letter of the law, you'll find things in the IRC that are just, close, but not quite.
Mm.
And that's deemed to comply because that's the way homes have been built for 50 years or more. And they seem to be acceptable. There's no performance issue. There's no problem, quote unquote problem. So the IRC is not strictly speaking something that most structural engineers are going to say, oh, I love it. We don't love it. We accept it. We understand it. And that's the important part because it's not compromising safety, but it's a balance between cost, efficiency, and safety. So with the bracing, it has a prescriptive method called the IRC prescriptive bracing method. And what you end up doing, a very quick overview. Actually, can I share my screen?
Yeah, sure.
Would that be possible?
Sure.
Okay, so I'm going to share an entire screen. All right.
Uh, Yep. I
So
can see it.
very good. What I'm going to do is bring over, this is the IRC. Can you see this?
Yes. The IRC code with the floor
Right.
plans.
And so basically what you do is you lay out, you look at each floor level, and you lay out what are called braced wall lines. And these are either vertical or horizontal lines. They're fictitious lines in that they don't have to line up exactly on a physical wall. They could be offset plus or minus 4 feet. So this braced wall line B, it actually doesn't hit any physical wall except down here, but it's picking up these two interior walls.
Mm-hmm.
And so you start by just saying, okay, this is what I think is going to work, right? And in the beginning, when you start doing this, you don't necessarily know. After a few times, you get to be pretty good at it. And the most critical thing is the on-center spacing between each one. And the middle one can be the average of the two on the side. But then, I'm just going to scroll down here. You come to another table, and depending on, of course, your wind speed,
Yeah.
we're just going to look at 95, but it goes up to 140. And depending on how many stories your house is, up to 3, and depending on what level of the floor that you're doing. So, for example, this one would be the second story of a 3-story building. Then depending on your braced wall line spacing and the method that you're using for bracing, you end up with what's called a kind of a base or a minimum level of bracing. So this would be 9.5 feet for this
Mm-hmm.
particular combination. Then you come down to this table and you have to make some adjustments to the
Mm-hmm.
number you just, the base number. That is dependent on your exposure category, dependent on the roof eave to ridge height, the story height, the number of braced wall lines that you have parallel on that particular floor plan, and a few other factors, right? So you end up getting these factors. And then what you do if I go back here, so what you do then is you look at your floor plan and you say, okay, I'm just going to say 1A. So you physically look at 1A and you've gone through and you've gotten all of your factors. This is your adjustment factor. This is your base number that you got from the IRC. You multiply these two, and you need to get 11.29 feet of bracing per this prescriptive method. Then you look and you say, okay, do I physically have that? Because you don't know until you get to this point whether you even have that. And so in
Yeah.
this job is 3 feet here. There's 2 feet 8 inches. And I'm just going to skip over for now, but for a portal frame, you can get up to 4 feet of bracing. And same thing here for a garage portal frame. So that's 8, 9, 10, 11, 12. That's 13 feet 8 inches, which is 13.6766 feet. So as long as this number is greater than that number, you've made it. There's other end conditions that for right now I'm just going to skip because it's getting a little bit more into the weeds. The challenge though is most of us do this with Excel or some kind of a spreadsheet. And if you didn't have enough bracing, right? For example, let's look at B. That's chipboard bracing, so I need quite a bit of bracing. And you can see I just made it, 23 versus 22. But what happens a lot of times is you can't make it. Like it doesn't, I might only have 20 feet of bracing and I need 22. So the most logical next step is to add another braced wall line in here, either here or probably here, because I've got more interior walls to work with, which is fine. But as soon as I do that, I've changed the number of braced wall line factors for all these other, or at least all the other parallel braced wall lines.
Yeah.
And I have to go back and recheck everything, which means if you add another braced wall line, you have to physically go into Excel and add another column here and add another row here. And it's just, if you're not under any time pressures, it's actually almost enjoyable because it's a puzzle.
Yeah.
And a lot of folks that I've talked to, they say, yeah, it's not bad. They've gotten used to the whole process.
Yeah, for our audio listeners, just so I can summarize this real quick, we were looking at some floor plans and we were scrolling through the IRC. And it is prescriptive, so it's essentially a table lookup method. So if your floor plan has X feet of wall, that can translate to the amount of bracing walls that you need. So it was essentially a lookup method, and we're looking at some floor plans and how much wall that we need. But like you were saying, if you don't meet the wall, then you got to redo this whole table lookup and all. It's an iterative process, which, can be tedious. So go ahead.
So, you can end up getting everything else to work, and then you get down to your very last wall or braced wall line, and it doesn't work. And so it's like, well, and because we do this at Keystone all the time, I've just thought this should be automated. And I've looked at what APA has, what Simpson and other companies have, and didn't see anything that came close to the way it's at least the way I do it, and the way I think most engineers would do it, or home designers. So what I did was I went on this venture of how do you draw a straight line with your mouse? How hard can that be? And not knowing, I'm not a programmer. I've become an amateur programmer working with C#, and this is with WPF, started exploring the whole world of the .NET ecosystem. So this is just kind of a similar layout that we were looking at before. It's minimal in bells and whistles. Everything is based on right clicking, but you can draw a horizontal braced wall line. You call it whatever you want. And I'm just going to quickly kind of go through, and you don't have to be exact in the first process. You just want to get kind of close. And then what you do is you have to set these parameters. Remember, we talked about that table. I have to tell the program what is the adjacent brace wall line. And if there's only 2, the program's smart enough to realize that's already checked. I only have 2 braced wall lines. I could have up to 5. The eave to ridge height let's just say it's not 16, but maybe 18 feet. And this is the first floor. And I'm going to say that this is a 2-story house. And let's just say the wall heights are all 10 feet. And I'm using this CSWSP, that's continuous sheathed wood structural panel. So you just go through, and once you set it for one, it defaults to the same values for each other. You can change them, and then for the vertical, because I've got 2 other lines, I have to tell the program what is the adjacent one. There's 3 lines here. Everything else for now, I'm just going to leave it to be the same. This guy, it's between 1 and 3, but in this case, the method is going to be JIP, because I'm going to be using a combination of JIP and wood structural panels. For 3, the adjacent line is 2. Also, I need JIP. Okay, and then we just have to calibrate it. And the one thing with my code is I have to have some dimension here that comes in on the original PDF. I don't in this particular case, not terribly important. I'm just going to say I'm going to calibrate vertically, and I'm just going to say that I know that this distance, and I'm making this up, is 30 feet. And obviously, the greater that number, the higher the bracing. But then what you do is you just come in here. I'm hitting Shift right click, and the red line is the 4-foot offset. And you can see that it automatically tells me how much bracing I need. And if I move this line, that number from 1431 will change. It decreased because I moved it closer, and the closer you move it, the less bracing you need. And I also moved it so I can include this wall right in here. So for time's sake, I'm just going to put in some bracing. It's not going to be perfect because I'm bracing over windows, and you can't do that. I'm just going to show you that as you add bracing, it detracts from what is remaining. And I've got 26. I only need 13. If I deleted that, and if I just put in between the windows, you can see that I'm building up. Yeah. How much I've provided. I still need 6 feet. And you can change. I mean, there you go. And then you can move these guys around if you have to. But you go through this, and then you also have to set the beginning and the end points of your braced wall line, because one of the requirements is that the bracing can't be more than 10 feet from the end of your line, of the end of your braced wall line, which is usually going to be the physical end of the building. It could also be another intersection of a perpendicular braced wall line. So for demonstration purposes, I'm just going to move this down a little bit. And again, forgive me for just going over windows here. But now I still need 5 feet. I'm going to leave it like that at this point to show you what happens.
Okay.
Because there we go. And then here, the same thing. I'm just going to, I got enough. Quickly go through this. Here it's JIP. And I've got a wall here. I've got to move that out of the way. There we go. So this is still potentially a little bit buggy. I still need 3 feet, but down here, I think I can put in some WSP. Well, just not quite enough.
Barely.
So, yeah, but the program would fail it. So I will do that for now. And, oh wow, look at that. I still need 5 feet. Well, let's see if I can. Oh, you know why I did one side right here? That's not right. I need 2 sides.
Double-sided.
Yeah. There we go. Set the top, set the bottom, and over here, there's not a whole lot of room here. If I move to like that, all right, so I can include this. There's 2 sides here, and I can use a portal frame here and here. And again, I may not. like you still need to understand the
Yeah.
IRC process. This is not 100% foolproof. It's just an aid, a graphical aid, but nonetheless, I think a useful one. And then finally, I want to add some dimensions. Oh, dimension. And if you need, let's sit in here. I don't know if that's operator error or a bug in the code, but you can shift to move these guys out. So finally, you do like a final check, and the code checks to see if you've set the endpoints at both ends, which I have. I meet my 10-foot end spacing.
Yeah.
My panels are 20 feet or less. But here you can see for brace wall line B, I only laid up 8.86 feet. I need 13 feet. So I can't
Yeah.
go any further. It's work in progress. So we go back to B and allow me to just cheat for now, guys. I'm sorry, just to get through this, but I'm just going to come in here and say, so now I'm at 0. Okay. I've provided 17 feet, but this would be an example of like, you have to go in and add another braced wall line. And when you do that, the program changes everything automatically for you.
Yeah.
But now
So, yeah.
I do a final check. All of this is passing. I hit show calcs and I immediately get the calculation table. And this is what a plans reviewer is going to look for. Obviously, this can
Yeah.
be edited. The end condition, I'm not going to explain it, but anybody who does this knows what I'm doing. It's part of the process. And you can also change the story, because sometimes you want it to be, a first floor or second floor. I'm sorry, a first floor. There's reason. It's hard to explain right now, but there is reason where you want to potentially edit this.
Mhm.
And then finally, you just print, and it's going to print both pages. It's going to print the layout, and it's also going to print these calcs. And somewhere right in here, these are the two files that we just printed. And
Yeah.
so it's still a work in progress, but it, compared to doing it manually, it's just so much easier. And the fact that you can come in here and you could just change the settings,
Yeah.
change the code, the speed. I mean, if I were to do 140D and then come back in here and do a final check, you see nothing works now
Yeah.
because
Hmm.
the required bracing went up significantly. And so it's, like I said, you still need to know the process, but it's been a work in progress. So we're just beginning to use this at Keystone. Today is like the formal official, showcasing of it.
Yeah.
I don't think anybody else has really seen it.
No, that's
And I
pretty
don't know where
cool.
it's going to go. It does really help get this done quickly.
Yeah. So if I could summarize it for the audio listeners, it's really cool. So with what the software does from is essentially you are working off a plan, floor plans, and if you've ever worked on residential and you're laying out shear walls or bracing walls, you typically do it on plan. You have to get it. So what was cool from what I saw was you're essentially working off a plan instead of doing spreadsheets. So you're marking up the walls, you're highlighting the walls, you're laying out the grid lines like you would do when you're designing walls. And what's cool is that it's as you're doing that, it's kind of like working off a blue beam, or if you're marking up plans, it does the calcs for you. It lays everything out for you. I've never seen anything like that in terms of something that I wish, because I used to do a lot of shear walls, and the process is similar. You're working off of plans, you're highlighting the walls, you're measuring the walls. So
Right,
that's what's really
exactly.
cool about it. Yeah, it's I wish that could be more implemented throughout the industry, because that's what's more natural, working off of plans.
Absolutely. And of course, this all started with me just wanting to figure out how to draw a straight line with my mouse, right? Like, how hard can that be? And surprisingly, I've discovered I enjoy programming. It's really become a passion. But I started, I got to that point, and then I said, all right, can I move the line? Can I do this? Can I do that? And a few years later, I've got what we've got. And now it's sort of like, okay, I wonder, could I add like a Simpson strong wall, or could I add a MyTech strong wall, or what else can be added here to make it more inclusive of everything that potentially can be used. Although currently Keystone, isn't using those other products. It's an interesting concept. But the thing, right, to go back to the IRC, the genesis, again, my opinion, is that there have been many high wind events where homes were totally devastated or just blown off their foundation. But the house right next to it looked like it was untouched.
Yeah.
Or relatively untouched. And neither house ever saw the light of day of an engineer. Like, they weren't engineered per se. And so the question is, like, what's going on? How come some homes survive and perform so much better than other homes? And so the IRC task group for this spent a lot of time looking at data, coming up with a prescriptive method that if you meet all of these criteria, here's the bracing that you need, and it should, withstand that particular wind design. So it's really hats off and credit to IRC and for that subcommittee for putting that together. It's just, it can be laborious, especially because you don't know if it's going to work until you get to the very end, and you can be off by 1 foot short. And it's like, oh man, you got to go back to the
So
beginning
close.
and add another brace wall line, or update all of your factors and make sure everything else works, right? Because sometimes other lines may not work because whatever. So anyway, that's the point of trying to automate this. Almost
Yeah,
done.
that seems really cool. I haven't seen anything like that in terms of software demos. Those where you're working off plans. I think not enough. I think most of the software companies focus on, just straight up calcs. But working off of plans and just marking it up, that seemed really cool to me because I do that all the time in Bluebeam. But it was like, man, if I could just get a software that could allow me to work on plan, that'd be so cool.
I try to reach out to Bluebeam because I use Bluebeam all the time.
Yeah.
And that's what I work. Like, I have markups, pre-made markups of everything I just showed you in the software. They're already pre-made up. Like, so I can just drag and it's like Bluebeam is so close.
Yeah. It's almost
But I couldn't get them to like get interested in developing that, I guess. So anyway.
Yeah, it's probably too niche, I guess, or yeah, I don't know.
Yeah, well, it is.
I did want to get into Gable and bracing because I think you guys do it in a unique way. What does a typical standard detail look like for Gable and bracing? What problems do you see with it? And how does your version at Keystone differ from it?
So because I've worked for both Alpine and MyTech, I have seen the standard Gable end bracing detail. I think anybody who touches trusses have probably seen it. And I looked at it, and it's detailed, but it's like, okay, I can kind of more or less follow it. But our director of procurement at Keystone called me and said, Jim, our trades, our framers are charging us like this. The coefficient of variation is too big. Some guys are charging us an arm and a leg. Others are hardly charging us at all just for Gable and bracing. Could you look into it? So that's what started me to like, all right, here we go. Let's start from the beginning and just analyze the details. So if I can share one more time. So I think this is a MyTech detail. It doesn't matter. It's a standard type of detail. And there are several different ways of bracing the gable end. The gable is vertical studs, and you've got a solid wall here. And this is what I would call a strong back type bracing, right? It's this, which works really well. But the whole point is you've got wind, either positive or negative, against the gable, and you have to find a way to get this force up into the roof sheathing, the diaphragm up here, or a combination of the ceiling. And the IRC does provide shear capacity for sheetrock. Part of the challenge is the details that are out here today do not address at all the connection to the ceiling sheetrock. But when I started looking at this, I said, okay, so you've got your vertical, and then you've got a diagonal, and the diagonal is braced and nailed to your vertical, but then it's also, you put blocking up here between your trusses, and the blocking is nailed to the sheathing, so it's perpendicular to the sheathing. But when you look at it and actually draw it out, it looks like this. This is your diagonal, because it's got nails going into the vertical studs. This is the roof sheathing, and it's at an angle because it's a gable. And you're putting nails between the roof sheathing and your blocking, which is exactly what they're calling out for here, right?
Yeah.
And then it says attach the diagonal to the blocking, which,
And it's all angled. Yeah.
And it's all, you calc. I mean, I've calculated this out. It all looks good until I like looked at that and said, well, so what, and part of the response is, well, this blocking has to be bevel cut, because the blocking still has to be nailed, shear nailed into the diagonal. And we don't have any framers that are going to bevel cut blocking in the residential market. Plus, if you're on the roof, all you see are the nails of the truss top cord. How do you know where this guy is if you're on top? You don't see it. So you need to have like an extra wide blocking, which, okay, I mean, it's not impossible, but it turns out we just don't have framers that even come close to following this, let alone, taking the time to really understand what it is you're trying to do. So that led me on another journey. And of course, the other method, and I'm only pointing out one type of bracing. There are several different methods in the industry, to be fair, right? And one of them is this L brace. I call it L brace, where you're running for strong axis bending, right? Because the trusses, the gable end trusses, are all weak axis bending as far as wind, perpendicular. And so what you do is you attach a either 2x4 or 2x6 into the gable end. But then what I did was, looking at the wind, I'm sorry for zooming in and out, I had to limit it to 115 mile per hour ultimate wind, exposure B. This doesn't work for 120 or greater, or exposure C, but it's a start. And the basic idea is, what you're going to do is, this might be a little bit easier to picture. You're going to nail into your gable end either a 2x4 or 2x6, and then you're going to attach or transfer half of that load into your ceiling diaphragm with flat bracing. And it can be staggered like this, but it's been capped out. And the only I'll say drawback is you absolutely need to have your ceiling jip attached at 16-inch on center, both field and perimeter, in order to calc out the load distribution. And on the top end, whether or not you can argue this will happen is another story, but you need to have at least 7/16 roof sheathing, which I think is pretty standard. But you do need to have 6-inch on center in order to make this thing work. But doing it like this, the costs are absolutely quantifiable, and it's helped Keystone in terms of just standardizing the costs. So of course, this has to be shipped out with the package of trusses that go out to the field, right? Because a building inspector isn't going to accept this from, he doesn't know Jim Collins from Billy Bob. And so I reached out to our truss fabricators and gave it to them. And I think it was Manheim Township in PA called me and said, well, this has to be blessed by my tech, which was the fabricator, right? Because again, they don't, this is not what comes on the truck typically. What they see on the truck is this, without my markups, right? And of course, the other side is, now I'm being a little judgy here, so forgive me, but I would go out to our job sites and I'd look up, and I would challenge any of you watching this to do the same. Go out to a residential job site after it's been framed and look at the gable end bracing. If you have, obviously a gable end, and just look at it. Like, take your time and study from an engineering point of view. How are the forces getting transferred to the roof sheathing or to the ceiling? And I can't blame the framers, because they have, they're being given something that takes an incredible amount of time to study and to read. And again, I'm not criticizing any company here. It's just, I don't care who you look at, SPCI has the same standard detail. And you just see so much wood going on, and they tie it into the web members of the adjacent trusses that are not designed to take any load. And so it just, I'll say it doesn't work on paper. I'm not saying it's not safe. I'm not saying that there's going to be any failure. It's just, so this is the result. And I just kept, and we field tested it. Like, we had our framers do this, and then they came back and said, well, what about piggybacks? And in the truss industry, that's the terminology, right? If you have a truss, depending on how great your span is, the height is too big to put on a truck without getting special permits, right? So there's several ways of doing it, but the most common way is you just cut your base truss off here, and then you build a little cap, which is not sure why, but it's called a piggyback. And
Okay, maybe piggybacks on top of the main
the piggy
truss. I don't
base.
know.
Yeah, it's a funny term, but that's what it's called. And so then the challenge from an engineering point of view is, okay, how do you make that work? And if, based on my analysis, and I have a ton of calcs I can share with anybody, it's horizontal shear that controls. Because as you bend this either in or out from the plane, you get horizontal shear that controls the connection. But the point is, I claim this works. It's a lot of nails. I mean, this is not easy to do, 3-inch on center, but at least it's something that's quantifiable that you can look at.
Yeah.
And then the field came back later and said, yeah, but now we have these bump outs where we have this little gable here. This is a gable, but now you have a girder truss, right? Because your roof trusses are framing this way, but then the front elevation, you have this little one or two, sometimes it's just field frame, but they're gables. So then basically the same idea. And I did reach out to Simpson to try to get some withdrawal values, and to their understanding, they weren't comfortable in providing any official withdrawal values. So, I mean, I've made some conservative judgments that what you're trying to do is get the withdrawal load, because the wind is blowing, this way. And you've got to get half of that load through all this into this, truss bottom chord. And I'm assuming an HUS 2.6, and it doesn't necessarily have to be that exact, but. And then finally, about a year later, they said, but we have these structural gables, that are gable ends, but they're structural. They're not pure gables, because you've got some trusses going on here. So it's the same basic idea, where this is the gable stud right here, and this is the L brace, and then this is the 2x4 piggyback brace. So you've got your brace, you've got your gable stud right here. You're putting a piggyback brace on top, nailing it to that. Then you're nailing your L brace into this guy right here. And again, in my calc, horizontal shear controls everything. So that's it.
No, that makes sense in terms of from the first detail that you were showing me, where they do the diagonal brace. It works on paper, but from looks like what you were saying from your experience, like it's hard to do in the field, and maybe the workers don't exactly get it right. It seems hard to get right, but with the detail that you were showing, it's you're nailing on 2x6s, 2x4s. It seems like basic carpentry versus trying to get a diagonal to work, nailing something pretty slanted, and you got to try to bevel it. It seems like that. What has been the feedback from the field when they're doing this?
If you ask a trade to do anything different from what they're currently doing, they're going to want to charge you more money.
Mhm.
It's it's just that's the way it is in residential construction. And so we had to work with some of them to point out that this is actually easier to do because gable ends are delivered to the job site with sheathing already on it from the truss plant. Okay. So you can put this, provided you have a flat space to lay your gable, you can put the L braces, nail them in place before you even install them.
Mhm.
Whereas the traditional detail, all of that pretty much gets done up into framing. And you don't have to send somebody up to try to do this because this is up high, right? I mean, this
Yeah.
is not as simple. You just climb up and do it. So there's a safety, well, potentially there's a safety issue involved. So to answer your question, I'm not there's pushback for anything I do with Keystone, right? I try my best to be able to defend the value that I'm adding if I'm adding extra cost, right? That's like number one rule. And so we got it in, like everybody's doing this and Keystone is happy with the pricing and the cost. I don't know the exact answer to your question, other than I'm told to look at something to
Yeah.
make it as efficient as possible. That's it. Like I don't even think about the cost. Like that's just not part of my calculations, I guess. So but we're doing this. And
Yeah.
Manheim Township has accepted. So my tech wrote a letter and contacted the building officials in Manheim Township, and of course I reached out to my tech, their engineers, and I gave them 50 pages of my calcs and walked it through. And it's been, I want to say, well received, but I'm not an objective observer on that.
Yeah.
I think it's been well received.
Yeah, like you were saying, whenever there's something new to do it, even though it's more efficient, there's always what they got to change, right? But then it's kind of like innovation. It's gonna be it's tough to get started, but then if it all works out in the end, like yeah, we should have been doing this the whole time. I don't know why would we ever go back to an old detail? It's kind of just I think it's pretty cool I know we're running out of time, but from the stuff that you showed me,
Sure.
it's pretty cool to see the innovation that's going on in residential. I think people might think, all the innovation is in like these big tech firms or whatnot, but even just these residential projects, they all have their own problems. They have constructability issues, and it's cool how you're integrating software, but also some new detailing that is showing the innovation that's still there. That's pretty cool. Yeah, I think I know we are out of time, but let's just ask one more question, the final question, just because we've been talking and I think we kind of just like got into it, right? Oh, time flew by.
Yeah, yeah.
But what's your final piece of advice for structural engineers who want to bring more
Well,
innovation into these code-driven design?
yeah, I don't know if I'm qualified to give advice after working in various industries and seeing how they integrate with each other. It's our current state of residential building is so layered that it became obvious to me and I'm sure to others that there's no one person who has ownership of the entire house in the building process. And you could
Right.
say, well, the home builder does, and obviously, they do for final price. But if you want to optimize your I joists, you do it on a price per square foot basis. So you take the price per lineal foot. I mean, this is 101. Everybody knows this. If you have two different I joists and one costs $1 per lineal foot, the other one costs $1.90 per lineal foot, this guy's more expensive. You're not going to use it. But if this has to be put in at 12 inches on center and this can be put in at 24 inches on center, you take your price per lineal foot, divide it by the on center spacing, and all of a sudden, like this one is $1 per square foot, right? $1 per lineal foot divided by 1 foot. But this one is going to be less than that because you're taking um, $1.90 or whatever I said, dividing it by 2.
Yeah.
So the price per square foot will be cheaper. So everybody knows that. That's not a big deal. So now you pick this But if you're not also selling the sheathing, then the layout of where those joists go might actually cost more money because you're sending out larger 4x8s for your floor sheathing that have to be cut, and you have more waste.
Yeah.
But the guy who's selling the I-joists doesn't care about that. Somebody's paying for it. Same thing, well, with the entire house, the foundation. There's so many trades involved that when you say, okay, what's the best combination of everything, when you include distribution, waste, I don't think anybody is capturing that. It's complicated, right?
Yeah.
So I'm not answering your question. I've off on a tangent here as far as advice. Try to understand the distribution of all the products that are being used in the construction of residential homes. And until you can do that and get a good handle on that, it's really hard to even attempt to make changes. One of the
Yeah.
things that I've seen, especially with my previous employer, offsite construction, where they're using, CNC saws. You design a house and it's meticulously designed. They translate that into machine code, send it to the saws on the floor, and they cut lumber to the nearest millimeter. Right, this was a big deal 5 years ago, and it's like, oh my God, you can ship out everything pre-cut, and it looks wonderful. You can build your floor panes and cassettes. But the problem is the foundation has to be perfect, and if it's not, if it's being done on the fly, you just adjust it accordingly. But if it's being pre-designed in a plant and cut accurately and then shipped out, it doesn't fit. You absolutely need to get as built dimensions. So it's difficult to give a simple answer to your question.
Yeah.
I think until we get AI equipment digging up foundations and excavating the ground accurately, and getting foundations poured as accurately as we can cut lumber, that's going to be the challenge, in my opinion. Getting the wood cut, I think we've got that mastered. Getting foundations poured, placed accurately, and poured efficiently, that's, we're doing it the same way, I think, that we've been doing it for decades. But as far as advice in general, I mean, I'm just going off on my tangent, so forgive me, guys. But as an engineer, what I've learned is I don't write emails that have more than 4 sentences. If they have more than 4 sentences, nobody's going to read it. I don't care how much time I spent writing it.
Yep.
I won't even read it if I see an email that's like a page long. So don't do
Yeah.
that. And if you can't say what you're trying to say in 4 sentences, print it out and hand deliver it as an old-fashioned memo if you want somebody to read it. But
Yeah.
that's just right. That's general advice. Never, ever, if you present, never use PowerPoint. And I know this is like the holy grail. Like, you've got to use PowerPoint. No, you don't. If you're truly able to talk to a group, write it out on 3x5 cards and look at the audience and just use that as a reference. If you have to use PowerPoint, use it only to put funny pictures up behind you, like silly cartoon type things. How many times have I seen well-meaning engineers put out something that's just mind-blowing? It makes the Gable and detail look like play school stuff. It's like, you look at this, you have 10 seconds to assimilate what they took, 3 hours to put together. It doesn't work. So that's it, and I would say, in my experience, learn something about public speaking. If you're out of school, obviously, just find a group, develop your public speaking skills. That has been so beneficial for me. And I'm not a great public speaker, but I don't use PowerPoint. And I just would encourage to help your own career, to just learn how to get in front of a group, and the way you and I are talking, be able to do that when you got 30 people or whatever.
Yeah. No, I think that's great advice. I think what you're saying with the communication skills, right? The email, oh yeah, so true. No one's gonna read a novel. And even just if you can't, if you need to use your PowerPoint to do your presentation, you don't know the material enough. Like you don't know how to precisely condense it so you can just get the important things out. So it's definitely true. So thanks
Oh, and one
for
last thing. Yeah, I'm
yeah.
sorry. One last thing.
Yeah, yeah.
Don't let your company put you on at 1 o'clock after lunch. Don't. The engineers are notoriously placed at 1 o'clock
Oh no.
with the intention. Now I'm being very judgy, so forgive me, all my previous employers, with the intention that, well, it's an engineer going to talk, right? Everyone's going to fall asleep anyway, so let's put them right on after lunch, and they won't. Just be mindful of that and try to push back.
To make sure everyone falls asleep after lunch. So man.
Well, I mean, you take it for what you want. I just know that if you want to really make an impact with what you're saying, make sure that you don't get scheduled to speak to a group right after lunch. That's all.
Thanks so much, Jim. I appreciate you coming on.
You're very welcome, Matt. It's been a pleasure talking to you. And
Yeah, this has been great. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.